What is thermal diffusivity and heat conduction? Imagine a hot cup of coffee cooling down on your table. The way the heat spreads from the coffee to the air and the table depends on how quickly the heat moves through the materials. That's where thermal diffusivity comes into play. It's a property that tells us how fast heat travels inside a material when heat is applied or taken away. To understand it better, think about heat conduction. This is the process where heat moves through a material without the material itself moving. It happens because of temperature differences inside the material. Some materials transfer heat very quickly, like metals, while others, like wood or plastic, do it more slowly. The ability of a material to conduct heat is called thermal conductivity. Materials with high thermal conductivity, such as silver or aluminum, transfer heat rapidly. Now, another important property is specific heat capacity. This is how much heat you need to add to raise the temperature of a certain amount of material by 1 degree. For example, water has a high specific heat capacity, meaning it takes a lot of heat to warm it up. Density is also key. It measures how much mass is packed into a given volume of the material. Thermal diffusivity combines these properties into one number. It is calculated by dividing the thermal conductivity by the product of the density and the specific heat capacity. The formula looks like this. Thermal diffusivity equals thermal conductivity divided by density times specific heat capacity. What this means is that if a material has high thermal conductivity and low density or specific heat, it will have high thermal diffusivity. This allows heat to spread through it quickly. Conversely, materials with low thermal diffusivity, like glass or brick, heat up or cool down slowly because heat doesn't move through them as fast. The units for thermal diffusivity are usually square meters per second. This tells us how fast heat can diffuse over a certain distance inside the material. It is especially important when dealing with changing temperatures over time, such as heating or cooling processes. Metals like silver or aluminum have high thermal diffusivity, so they respond quickly to temperature changes. Materials like brick or glass have low values, making them good insulators because they resist rapid temperature shifts. Knowing the thermal diffusivity of a material helps engineers design better systems for heating, cooling, or insulation. It explains how quickly heat moves inside materials during non-steady heat conduction. This property is key in many applications, from designing efficient heat exchangers to understanding how buildings retain or lose heat. It's a simple idea but plays a big role in how we manage energy and temperature in everyday life.